third step, 3 out of 4 that we're doing today, is noticing living things. And this is an argument that was made famous by William Paley at the end of the 1800s. Yeah. You see what I got here, Lee?
My watch, intricate pocket watch.
Excellent, excellent. So, everybody look. Okay, no, I'm not going to do that. Yeah, this is my grandfather's pocket watch. And William Paley famously wrote a story about, well, if you were walking along and you happened upon something like this and looked at it, would you conclude that somebody had made it or that it had happened by itself, naturally? And of course he said, well, you'd conclude that somebody made it. Well, then Darwin came along, because Paley wrote, I think, at the end of the, the end of the 1800s, at the end of the 1700s. And then Darwin came along with his Origin of Species and purported to demonstrate how natural forces, by a step-by-step gradual process, could in fact accomplish something like this. So that seemed to end the argument right there.
Throughout the second half of the 20th century, spectacular technologies revolutionized scientific understanding of the cell, the basic unit of life. During an interview with biochemist Michael Behe, Strobel learned how this new knowledge has shaken the foundations of Darwin's theory.
In the 19th century, when Darwin was alive, scientists thought that the basis of life, the cell, was some simple glob of protoplasm, like a little piece of jello or something that was not hard to explain at all. But with the hard work of science in the 20th century, we've seen that the cell is far from simple. It's got very complicated molecular machines and things that are very resistant to Darwinian explanation.
Michael Behe has devoted his career to the study of the design and operation of the cell. He has also written extensively on the biochemical challenge to evolution.
Most people have no idea of how small and complex cells are. A typical cell from you or me, called a eukaryotic cell, is probably 1/10 of the size of the head of a pin. And yet in that single cell, there are about 3 billion units of DNA making out the chromosomes. And those 3 billion units make the molecular machines of the cell, literally machines that make the cell work.
With computer animation, we can enter the cell. Here, the staggering complexity of its molecular machinery is clearly seen.
It's like going into an automobile factory. The factory has a large number of machines. The parts have to fit together in very specific ways to do their jobs, and if things go wrong, the cell is in big trouble. And just one cell is enormously complex, but humans, you and I, are made from trillions of cells, and those trillions of cells have to fit together in the right way and do their own job. Darwinism was a lot more plausible when we were thinking about globs of protoplasm than it is when we're thinking about molecular machines.
Each of these biochemical machines is a masterpiece of engineering and nanotechnology. They are essential to functions as vital and diverse as vision, photosynthesis, and the production of energy in the cell. Michael Behe has studied several of these machines, including the flagellum, a remarkable rotary motor.
I remember the first time I looked in a biochemistry textbook and I saw a drawing of something called a bacterial flagellum with all of its parts in all of its glory. It had a propeller and the hook region and the drive shaft and the motor. And I looked at that and I said, that's an outboard motor. That's designed, that's no chance assemblage of parts.
Behe's reaction was not surprising. especially when the bacterial flagellar motor is animated and magnified more than 50,000 times to display the details of its construction and operation.
Howard Berg at Harvard has labeled it the most efficient machine in the universe. These machines, some of them are running at 100,000 RPMs and are hardwired into a signal transduction or sensory mechanism so that it's getting feedback from the environment.
It's got some tail proteins which act as the propeller. When the flagellum rotates, these push against the water and therefore push the bacterium forward. And the motor uses a flow of acid from outside of the cell to the inside of the cell to power the turning.
The bacterial flagellum has 2 gears, forward and reverse, water-cooled, proton motive force. It has a stator, it has a rotor, it has a U-joint, it has a drive shaft, it has a propeller. It's not convenient that we give them these names. That's truly their function.
In all, about 40 different protein parts are required to build a flagellar motor. Half of them are constructor proteins, specialized mechanisms that assemble the flagellum's individual components. Since its discovery, biologists have tried to understand how a machine of such superb design could have arisen gradually, without foresight or plan, through the biological pathway Darwin envisioned.
I think what Darwin was trying to show was that things that look designed aren't really designed, but that we can find naturalistic processes to account for the complexity of life. Darwin theorized that every part of every living organism evolved through natural selection, a blind process that acts upon random changes in the cell.
Darwin believed that, given enough time, these random variations would transform the simplest cells into the great diversity of life that inhabits our planet.
Of course, not everyone's convinced, and there is some controversy about whether the case has been proven. But what Michael Behe is famous for is coming up with his description of what he calls irreducible complexity. And so he uses the bacteria flagellum as an example of that. Something, a nanomachine with 40 different protein parts that all have to be present in exactly the right way at the same time in order for the flagellum to work. And he likens it to a mousetrap. You know, if you have a simple mousetrap and you are missing one part of it, like the spring or the catch or something like that, you don't just catch fewer mice as you would on a Darwinian take of things, where you gradually add one more piece after another and it gets better and better in its function as it goes on. No, you don't have something that works a little bit, you have something that doesn't work at all, until you get everything together precisely at one time and in one way. And he says that's the same thing that you see in the bacteria flagellum, is you have a nanomachine with several different inner working parts. They all have to be present together at the same time. And that can't be explained by a gradual step-by-step Darwinian process. Now, of course, the critics say not so fast. We can tell you a story about how that might have happened, because we've got some things over here that are a part of a different machine in the cell, and we have some things over here that are part of a different machine in the cell, and some of those could be lying around and they could have just kind of come together haphazardly, and boom, you've got it. So you don't have to have exactly everything laid out the way you're talking about. Okay, well, what I've noticed about Darwinian explanations is that they are good stories. They're interesting stories. They don't have the kind of evidence that we're looking for that would support them in terms of, okay, demonstrate to me how that could possibly have taken place. But it is a plausible story. The other factor to consider, though, in this irreducibly complex nanotechnology is what was mentioned in the video, and that is the assembly instructions. You know, that about half of the proteins involved in the process, the narrator said, guide the assembly of these nano machines. And that's something that's never, to my knowledge, has never been addressed by the Darwinian literature. What can account for the very complex assembly instructions about how to put these things together that have got to be put together in a very precise order? You know, for the bacterial flagellum, it doesn't all come together in a glob. You got to do one thing after another, just like when you build a house. You got to put the foundation up first, the framing, you know, the wiring before you put the siding on and so forth. Well, I have been told by a couple of different sources that there are very few astronomers and astrophysicists who are atheists these days. So the evidence for a beginning that is immaterial and eternal seems pretty convincing to many astrophysicists. Now they're not ready to embrace the Christian God, but an example of some of the movement that's taken place in recent decades on this is the most famous atheist of the 20th century, Anthony Flew, a philosopher. In the mid-20th century, he made himself known as a very articulate spokesman for the atheistic point of view. And I remember studying him in philosophy class in college. Well, in just this past decade or so, he changed his mind, and he became a theist. He said, you know, the evidence to me for intelligent design, and he was thinking of the kind of things that we were talking about today, to him seemed convincing. Now, he was not willing to embrace a Christian God, but he was willing to get as far as deism, you know, some kind of creator that created things and got them going. And he was open to, you know, to considering other things. Well, here's one common objection to the fine-tuning argument, and that is multiple universes. Now, I mentioned it last week in the context of Stephen Hawking's book, The Grand Design, where he asserts that the example of quantum events and M theory makes possible, likely, or maybe even more than likely, the existence of multiple universes. He says 10 to the 500th alternate universes. And of course, if there are universes bubbling up all the time, with different settings on these physical constants, then eventually you're going to get one with everything just right. No direct evidence of this. And it seems to me to be a lot of wishful thinking on the part of people who are uncomfortable with this evidence, with the way things are.
The fine-tuning of the laws and forces of physics is so precise that few theorists are comfortable invoking mere chance as an explanation, unless our universe is not the only roll of the dice.
If the universe looks like it's fine-tuned for complex life, maybe there's a fine-tuner. Maybe it was fine-tuned for life. And this has certain unsavory theological implications. And so it's not surprising that those committed to a fundamentally materialistic view of reality would try to find an escape hatch. And the most popular escape hatch for this theological implication of fine-tuning is this idea of multiple universes.
As its name suggests, the theory of multiple universes proposes that our universe is not alone. Instead, it is part of a vast ensemble of universes, each with a different set of laws and constants.
If there's only one universe, then the conclusion that the universe looks fine-tuned because it is fine-tuned is inescapable. But if our universe is just one of a vast set, then you seem to have more resources to play with. Chance gets a new lease on life. I sometimes try to imagine what physicists have in mind that postulate this idea of multiple universes. I mean, what would the generator look like that creates them? Maybe it's like a giant monolith that has dozens of different dials, each of which has to be set to the right physical constant.
If we think of these parameters as dials, each of the dials is different. So if you produce enough universes with enough different dial settings, eventually, just by chance, you get one just right. So you might have to produce a trillion universes. But eventually, if you have a generator that's just spitting out just an enormous number of them, then it gets the right dial setting. And then, by just chance, you get conditions right for life. So it's a huge cosmic lottery. That's the idea.
It's an interesting idea. I mean, there's really only one problem with it. There's no independent evidence that it's true. Besides, it really just pushes the question back a step, because we could still ask, who built the generator?
The suggestion of multiple universes strikes me as a desperate attempt to explain away the obvious, which is that the universe is finely tuned by an intelligence to sustain complex life. An intelligence that must be beyond the constraints of time and space.
Okay, here's another one objection, and that is that you don't give natural selection enough credit in the Darwinian story. This, of course, is the reigning paradigm among science. All of our schools is teaching Darwinian evolution, neo-Darwinism, which basically is that biological things are different from each other, and you see that the ones that are best adapted to their situation tend to reproduce and get their genes into the next generation. And so the next generation tends to be more and more like the ones that survive and get their genes in the next generation. And these variations tend to be selected for naturally, natural selection. Sort of like breeding, which is artificial selection. You can create a certain type of cattle or dog or species of corn by artificial selection, and we can see natural selection having the same type of effect on the earth over time. The question is that a powerful enough mechanism to account for all the differences in organic life that we see today? The Darwinists say yes, the non-Darwinists say no. And there actually are many problems with Darwinism, which if we're able to spend more time on it during the summer, we'll explore them. But just getting started is a big problem. And this table over here was discussing the problem of the origin of life on Earth, and how the best explanation going now is not the organic soup, but seeding from outer space, and the excitement over whether we can find water or even an organic molecule on Mars, because maybe that then tells us how life could have got here from Earth, by a meteorite from Mars. But despite all these objections to Darwinism, people aren't convinced. And one of the objections to the objections is that, well, if you got some super intelligent designer, why all the bad design? We don't have perfect design in the human body. I mean, it's interesting and remarkable. We don't have perfect design. So how do you account for that?
Design, but it's designed from the bottom up by a natural process of evolution, and that's why it looks tinkered and not very well designed and sort of patchworked and put together from previous organisms and structures and functions and so on. It doesn't look to me very well intelligent design.
Good point, Stephen. How do you respond to those?
Well, I think it's exquisitely designed, especially when you look at what's going on at the molecular level and the information processing system that is the basis of all living systems. He's made the argument, for example, that the eye is not well designed because the wiring appears inverted to some physiologists. But others dispute that and say that the vertebrate eye is an exquisitely designed system that represents what engineers call constrained optimization, where many factors have been optimized to achieve the best overall functionality. So this vertebrate eye that evolutionists say is not well designed, that looks tinkered with, is actually the same eye that eagles use to achieve this incredible visual acuity that they.
You know, the eye that Michael Shermer, the other guy in there, would propose as superior, you know, has some good features to it. But an article I read about it said that it wouldn't last very long. It lasts for about a year before the radiation damage would make it unusable. And so part of the constrained optimization that Stephen Meyer was talking about in the engineering is that it's built for longevity. You know, it'll work for a long time. You know, the SETI project, a search for extraterrestrial intelligence. And the movie Contact made it famous by saying, you know, if we found a series of prime numbers coming out of the galaxy, we'd know that there's some intelligence out there. What we found is a similar thing in DNA. Not a series of prime numbers, but actually a cookbook, a recipe for creating and building proteins, and the instructions for how to put them together.
The existence of complex biological machines raises an obvious question. If natural selection wasn't the agent of their construction, then what was? The centerpiece of my investigation was an interview with philosopher of science, Dr. Stephen Meyer. Meyer, who holds a PhD from Cambridge University, brought me face to face with the most efficient information processing system in the universe. The DNA molecule and its language of life.
The discovery of the information-bearing properties of DNA and RNA is a fundamental challenge to all materialistic theories of the origin of life. Neo-Darwinism and its associated theories of chemical evolution and the like will not be able to survive the biology of the information age, the biology of the 21st century.
Meyer's conclusions are based upon his understanding of the DNA molecule and the genetic instructions that are locked within the nucleus of living cells.
In 1953, when Watson and Crick elucidated the structure of the DNA molecule, they discovered that DNA was a carrier of genetic information in the form of a 4-character digital code. That is to say that DNA functions like a software program, only more complex than anyone has ever created or devised. For a biological system to run and operate, it needs genetic information to build the proteins and protein machines that cause the cells to maintain their function.
This information is stored in a precise arrangement of 4 chemicals that scientists represent with the letters A, C, T, and G. Sequences of these chemicals provide the instructions necessary to assemble complex protein molecules that in turn help form structures as diverse as eyes, legs, wings, and hearts. This code has been called the language of life, and it is the most densely packed and elaborately detailed assembly of information in the known universe.
Geneticist Michael Denton has estimated that the amount of biological information necessary to build all of the proteins in all of the species of organisms that have ever existed on planet Earth could be held in a single teaspoon. And we'd still have room left over for all of the information contained in every book ever written. The more I learned about DNA, the more I understood the significance of what Stephen Meyer called the most fundamental question facing biology today. Where did the information in DNA come from? How did it arise in the first place?
Well, lots of people have wanted to explain the origin of information by reference to the laws of physics and chemistry, or by reference to the chemical properties of the constituent parts of the DNA. But that would be like saying that you could explain the information in this morning's New York Times headline by reference to the physics and chemistry of ink bonding to paper. There is a chemical explanation as to why the ink sticks to the paper, but that does not explain the way the ink got arranged to convey a message that could be understood by speakers of the English language. Information requires a material medium, but it transcends the material medium.
An explanation for the origin of the genetic instructions needed to build the first life is the holy grail of 21st century biology. Theories proposing that this information arose through natural selection acting upon non-living molecules, or the self-organizing power of chemicals in a primordial soup, have repeatedly failed. Even time and blind chance, the oft-invoked saviors of implausible biological scenarios, have fallen far short as accounts for the source of the instructions in DNA. Mathematicians, for example, have calculated that a universe filled with monkeys, typing relentlessly throughout the oldest estimated age of the cosmos, would have no realistic chance of producing Shakespeare's play Hamlet, let alone a transcript of the genetic information required to build even the simplest living cell.
Based on our uniform and repeated experience, which is the basis of all scientific reasoning about the past, there is only one known cause for the origin of information, and that cause is intelligence. Whether we're looking at a hieroglyphic inscription, a section of text in a book, or a computer software, if you have information and you trace it back to its source, invariably you come to an intelligence. Therefore, when you find information inscribed along the backbone of the DNA molecule in the cell, the most rational inference, based on our repeated experience, is that an intelligence of some kind played a role in the origin of that information.